All right, so that looks like a 1 squared. That's supposed to be a 12. So suggestions, how should I start this problem?
You put the constant 12 in front.
I could do that. I could move the 12 to the front. So I'll have 12, 1 over t cubed minus 6t squared dt, 1 to 2. Now what? Actually, let me ask some different questions. Would a substitution work here? Could I do a u sub? That's not promising. So the answer is that u sub, actually we'll do this in this color, u sub won't work because we need the derivative of t cubed minus 6t squared, which is 3t squared minus 12t, but we don't have it. Okay, so that means u sub's out. This is clearly not an integration by parts problem. I have 1 over t cubed minus 6t squared, which we can't even integrate, so that's not it. Is this a rational function?
Yes.
Yes, this is rational, which tells me that partial fractions is going to be the best bet. Okay, so for the first thing, the first step of partial fractions is to divide if necessary. Do I need to divide here?
Nope.
Nope, no division necessary. Then my second step is to factor the denominator. So t cubed minus 6t squared, we'll start with the greatest common factor. What is it? What's the GCF here, guys? T squared. Yes, thank you. Squared times t minus 6. That's factored. So now this brings us to our third step, which is our partial fractions decomposition. So I have 1 over t squared times t minus 6. How many times does the t occur? Two times, which means it gets 2 fractions all to itself. So I have a over t plus b over t squared. Each time I'm increasing by 1. How many times does the t minus 6 occur? One time. So that means it gets 1 fraction to itself. Now my fourth step is to solve for the numerators. And to solve for the numerators, the first thing that I'm going to do is multiply both sides by the original denominator. So I'm taking everything and multiplying it by t squared times t minus 6, which means that I will have 1 is equal to a. One of the t's cancels out, so times t minus 6, plus b, both t squareds cancel out, so times t minus 6, plus c, the t minus 6's cancel out, times t squared. Now we plug in our zeros. What zeros do we have here? 0 and 6. Thank you, Dylan. So first I'll start with 0. T is equal to 0. So I get 1 is equal to 0 plus b times negative 6 plus 0. So b is equal to negative 1/6. Then my second one we said is 6, so t is equal to 6. So I get 1 is equal to 0 plus c times 6 squared. So c is equal to 1 over 36. Now I don't have any more zeros, but I still haven't solved for a. So what should I do? use 1 as t. I could also use 84 or 84,846,943. But 1 is easier, so I'm going to let t equal to 1. I'm picking a random value of my choice. And when I let t equal to 1, I have 1 is equal to a times 1 times -5 plus b times -5 plus c times 1. So I get that 1 is equal to -5a minus 5. Well, I know b is -1/6, so times -1/6 plus c, so that's plus 1/36 times 1. So 1 is equal to -5a plus 5/6 plus 1/36. So 5a, I'm adding 5a to both sides, will be 5/6 plus 1/36 minus 1, which is 31 minus 36. So 5a is equal to -5/36, which tells me that a is equal to -1/36. Everyone understand the math that I just did there. So first we plugged in a random t value, and then we plugged in the b and c that we had already solved for, which allowed us to then find a. Okay, good. So now we rewrite this in the integral. So our integral is -12 out front, -1/36 over t. Notice I'm not moving that 36 down to the bottom. I'm keeping my fractional exponent up top, plus -1/6 over t squared plus 1/36 over t minus 6. And all of these are known forms. So be careful. That first one is a ln. So this is 12 times -1/36 ln t. Is that second one also a ln? No. So I'm going to go off to the side and do it because a lot of you messed this up on your second tests. The integral of -1/6 over t squared is -1/6, the integral of t to the -2 dt. So this is actually just a power rule. So this is -1/6, t to the -1 times -1 plus c. So this is +1/6t. And then the last one, is the last one a ln? The last one is a ln because that t minus 6 is to the power of 1. So this is 1/36 ln of t minus 6 plus c. Now I'm going to distribute that 12 to get -1/3 ln t plus 2/t plus 1/3 ln of t minus 6 plus c for my final answer. Are there any other questions about this problem? Are there any other specific questions that you guys want me to do? Okay, so Sophia said series. So we're gonna go and look at the series from this same exam. And I think that that's gonna be important because, I mean, hopefully you guys have advanced since your quizzes, but they really did not go very well. So we're gonna start with question 13. How can you integrate Is this what you're asking, Maylee? So there are two ways to do this. We could just say u, we could say u is equal to x minus 2, so du is equal to dx, and get u squared du, 1/3 u cubed plus c, which is 1/3 times x minus 2 cubed plus c. So that would be one option. Or we could expand and say this is x squared minus 4x plus 4 to get 1/3 x cubed minus 2x squared plus 4x plus c. Okay, so we're going to do question 13, which combines sequences and series. So we have a sub n is equal to 5, 2n factorial over 3n times 2n minus 1 factorial. And the first question is, does the sequence converge or diverge? And the second question is, does the series converge? Okay, so to determine if a sequence converges or diverges, we start off with a limit. So for A here, I just need to do a limit. And I couldn't help but notice that on your quizzes, most of you just wrote, looks like it converges or looks like it diverges, and did not write limits. We have to write limits. So limit as n approaches infinity, 5, 2n factorial over 3n times 2n minus 1 factorial. Can I just like cancel out those factorials? I don't want them, they're gone. Can I do that? No, I definitely cannot. So how do I deal with a ratio of factorials? I take the bigger factorial, so in this case that's 2n factorial, and I expand it until I get to the smaller factorial. So now in this limit, I'm going to rewrite my factorial. And I'm going to cancel out those factorials. Goodbye. What does this limit equal? Ten-thirds, you got it, Dylan. So I can cross out those n's and say that this is equal to 10 over 3. And what that tells me is that the sequence a sub n converges to 5/3. Now what about B? What does the fact that that converges tell me about the series? Wow, I love how I said 10/3 and thought 10/3 and wrote 5/3. So what does that tell me about the associated series? What that tells me, 10/3 does not equal to 0. So what that means is eventually it's like I'm adding 10/3 over and over again forever, which is clearly going to be infinite. So the fact that it doesn't equal 0 tells me that this series diverges by the test for divergence. And we'll just remember over here, if I can spell remember. Remember, the test for divergence fails if limit as n goes to infinity of a sub n equals to 0. Okay, are there any questions about this?
Okay, so the fact that it converges to 10/3 means that it's not equal to 0?
The fact that the sequence converges to 10/3 means that the series diverges.
Okay.
Right? So it's the difference between a sequence and a series here. And we're going to really test that idea again in question 14 here. So question 14 says, if the series n equals 1 to infinity, a sub n converges, then the sequence and we're going to fill this in with either might, cannot, or must. The sequence might converge to 0, must converge to 0, or cannot converge to 0. What do you guys think? So this is just the definition of the test for divergence. So the answer here is actually must. And this is must because the test for divergence tells me that if it doesn't converge to 0, so like that 10/3 up there, if the sequence does not converge to 0, then the series diverges. Does this make sense to you guys? And so here we're saying, hey, look, I know the series converges, which means the sequence had to have converged to 0, because if it didn't, then the series would have diverged. Are there any questions about that? Okay, so I'm going to write down all of the series for 15, and we'll just think about them individually while we can look at all of them. Okay, so we have 4 series here. I'll give you guys a second to kind of get them down. And then we're just gonna, before we do any of them, we're gonna discuss how we would do them. I'm gonna grab water while you guys are getting them down. Let me know when you guys are ready to talk about them. Okay, awesome. So let's think about what we did in class about our list of thoughts that we need to have about how to approach a series. So the first question we ask ourselves is it a p-series? The second is it geometric? So let's just look at A. Is A p-series? Okay. Is A p-series? Come on, guys. You're gonna have a test on this tomorrow. If you're not able to recognize if something is a p-series, you have a lot of work to do before tomorrow. Is A p-series? So the answer is no, it is not. What does a p-series look like? What's a p-series look like? C over n to the p. Good, so it's n to the power of a number. I have an n to a number, but do I also have like a number to n? So this is not a p-series. Okay, next question. Is this a geometric series? I'll remind you, geometric series are numbers to the power of n, but only numbers to the power of n, nothing else. Is this a geometric series? No. What stops this from being geometric? You got it, that n plus 1 to the 5th. Okay, so let's move on. B. Is B a p-series? No, not a p-series. Is B a geometric series? Yes-ish. So it's not a geometric series, but remember we said if we have a plus in the numerator and one thing in the denominator, we can separate. So this can be separated into 2 geometric series. So we have identified the way that we are going to do B. Okay, let's keep going. Is C a p-series? Okay, so it looks like maybe it's a p-series, but for a p-series, Parker, you're right, it's not a p-series because a p-series is literally just a constant over n to the p. I have minus n minus 2. 1 over n squared is a p-series. 1 over n is a p-series. 1 over n squared minus n minus 2 is not a p-series. So it looks like a p-series, but it's got a full polynomial down there on the bottom. So this is not a p-series. And then we said it looks like a p-series, so it's also not a geometric series. Okay, what about the last one? P-series, geometric series? Is it a p-series? No. Is it a geometric series? No. Okay, so the next thing we said is if it's not a p-series and it's not a geometric series, does it contain a factorial or contain something that looks geometric? Like an exponential, like a number to the n. So the first one, does it contain a factorial or part of a geometric series? Part of a geometric series. If it does, then that means we apply the ratio test. So here this contains a number to the n and not geometric. So apply the ratio test. Okay, so we figured out how we are going to do A when it comes time to it. We already figured out how we're going to do B, so I'm going to skip it. C, does it contain a factorial or something that looks geometric? Does it contain well, let's start with that. Does it contain a factorial? No. So this is no factorials. And does it contain a number to the n? No, it doesn't. No number to the n. Good. What about D? Yes, and we will, Dylan. We'll get, yeah, we're going to do that eventually. Okay, so wait, so we're going to say this is probably not ratio test. Okay, so what about D? Does D contain any factorials or things to the power of n? There's not a factorial for D. Factorial would be if we had an exclamation point. Okay, so D also no factorials, no number to the n. So probably not ratio test. Okay, after that, after we've eliminated the possibility of a ratio test, we go back and we say, let's try the test for divergence. So we're going to try the test for divergence on both of these two things. And if the test for divergence fails, what's the only thing we haven't thought about yet? You got it, Dylan. Telescoping. Do either of these look like they could be turned into a subtraction? So remember, we can use lns or partial fractions to turn something into a subtraction. Does that look possible for C or D? Okay, so a tip is if you have something that looks like a p-series but is not, and the denominator factors, it's probably telescoping. Oops. All right. Also, I would like to point out D kind of like B could be separated into geometric series, D could be separated into P series. We're going to try the test for divergence. If it doesn't work, then we'll go back and think about that. So could also okay, let's do it. For A, we're applying the ratio test. You guys ready? All right, let's apply the ratio test. So the ratio test says, do the limit as n approaches infinity of the absolute value, oops, of the absolute value of the series, but I'm gonna plug in n plus 1. So I'll have n plus 2 to the 5, 2 to the n plus 1, over 5 to the n plus 2. So every time I had an n plus 1, an n, I wrote n plus 1 instead. So that's a sub n plus 1. Then I take my original thing and I flip it over. So I have 5 to the n plus 1, n plus 1 to the 5th, 2 to the n. So this is 1 over a sub n. So then we use our exponent rules. 5 to the n plus 2 is equal to 5 to the n times 5 squared. 5 to the n plus 1 is equal to 5 to the n times 5. And 2 to the n plus 1 is equal to 2 to the n times 2. So this is equal to the limit as n approaches infinity, n plus 2 to the 5th, 2 to the n, times 2, times 5 to the n, times 5, all over 5 to the n, times 5 squared, n plus 1 to the 5, 2 to the n. And then we cancel stuff out. So goodbye 2 to the n, goodbye 5 to the n, goodbye 5. To get n plus 2 to the 5th times 2 over 5 times n plus 1 to the 5th. And how am I going to go from here? Suggestions? What do I do when I get to here with the ratio test? To be noted, it's always the same thing. Come on, guys. It's always the same thing at this point. How do I do this limit? How am I going to evaluate this limit? Okay. Yes, good job. We're going to take the big stuff. Could I also do L'Hopital's rule if I wanted to? Yes, so this is either HR or take the big stuff because it's a polynomial over a polynomial. So n to the 5th times 2, 5 times n to the 5th, which gives me the limit as n approaches infinity, n to the 5th times 2 over 5n to the 5th, and those n to the 5ths cancel out. And what does this limit equal? You got it. So it equals to 2/5 For the ratio test, we're always comparing to 1. So 2/5 is less than 1. So what does that tell me? Does this converge or diverge? You got it. So this converges by the ratio test. And can I find the sum? Can I find the sum here? The only time I'm able to find the sum is if it's telescoping or geometric. So here we can say, but this is not telescoping or geometric. So we cannot find the sum. Okay, any questions about that ratio test? Good. So let's move on to B. Now B, we said, was geometric. I'm so jealous that you were outside, Jay. I wish I would have been out there. I'm really nervous about this test for you guys. Where'd my problem go? It's gone. Okay, so we said it was geometric, but we had to separate it. Yeah, I'll post the video. So then this is equal to the sum. N equals 1 to infinity. We end up with 1 over 3 to the n minus 1 plus the sum, n equals 1 to infinity of 2 to the n over 3 to the n minus 1. You're going to get 100? Well, I'm nervous because nobody seems to know what they're doing. And it's tomorrow. But Jonathan's going to get 100, so we're all good. Okay, so here we said that plus means I can separate it. So now we've separated it and we have 2 series. So we're going to call this star and we'll call this smiley face and we'll look at them separately. And star is entirely numbers to the power of n. We have that 1 on top, but I can think of that as just like 1 to the n. 1 does not matter. Constants don't matter. So this is 1 over 3 to the n minus 1. So this is geometric. What's my r here? Largely, Laura, I'm nervous because I really want you guys to do well. Even though it was online, I want to know that you learned things. So R is 2/3 for smiley face. What is it for star? So I have a 1 in the numerator because there is nothing to the n. So my R tab is 1, exactly, Caitlin. Then I'm going to have a 3 in the denominator. So my R is 1/3. And 1/3, the absolute value is less than 1. So it converges. Now what about over here? Here in the top I have a 2 and in the bottom I have a 3. And again the absolute value of R is less than 1, so again it converges. But these are geometric, so can I find the sum? Yes. So let's just remind ourselves, geometric series converge to A over 1 minus R. How do I find A? Exactly. I'm going to plug in that n equals 1. So a over here will equal to 1 over 3 to the 1 minus 1. Well, hey, guess what? That's just 1. And a over here will be 2 to the 1 over 3 to the 1 minus 1, which is just 2. And now we can plug in to a over 1 minus r. So I get 1 over 1 minus 1/3, which is 3 over 2. And then over here we have a over 1 minus r is 2 over 1 minus 2/3. So my final answer here is that this converges to smiley face plus, or actually star plus smiley face, which is equal to 3 over 2 plus 6. So this converges to 15 over 2. And here we could find the sum because it was geometric. Okay, any questions about that? Linear does not require this stuff, no. Linear kind of is off on its own. Okay, so I'm going to skip C. We'll go back to C and do it last. And I'm going to do D. And I'm going to do D in 2 different ways. Okay, so up here, when we had done D, when we looked at D, we said D is not a p-series. D is not a geometric series. There are no factorials and no number to the power of n. So maybe we should try the test for divergence. So that's what we're going to do down here. And we're going to look at option 1, the test for divergence, which tells me to just apply that limit. Okay, how do I do a limit like this? So it's infinity over infinity. It is going to give me 1 over 10 though, because I can just take the big stuff. So I'm taking the n squared, and then I'm taking n squared again, and then I'm taking that whole 10 into the 4th. So I have n squared times n squared over 10 into the 4th. All of that n cancels out, giving me 1 over 10. Does 1 over 10 equal to 0? No. So this diverges by the test for divergence. Now, option 2 is to just see if maybe this actually is a p-series. So I'm going to expand the numerator. Like this. And I'm going to get into the 4th plus 2n cubed plus 1 over 10 into the 4th. which gives me the sum n equals 1 to infinity of 1 over 10 plus 2 over 10n plus 1 over 10 to the fourth. And what we can see is that this is a p-series with p equals 1, so the harmonic series, so it diverges. And we know that if part of it diverges, the whole thing diverges. The test for divergence was easier in this case. What about this series right here? Does this one converge or diverge? This one converges. This is a p-series. P is equal to 4, which is greater than 1, so it converges. What about 1 over 10? Does that converge or diverge? What's the limit as n goes to infinity of 1 over 10? 1 over 10. So that actually, this diverges by the test for divergence. So I have diverges plus converges, that clearly diverges. All right, last one. Oh, thank you. It is C, isn't it? Whew. Ooh, I'm sorry I'm so yawny, guys. Okay, so here we had gotten to the point where we were like, it's not a p-series. It's not a geometric series. It doesn't contain factorials or numbers to the power of n, so probably not ratio test. So we're going to try the test for divergence, but we're also going to recognize that n squared minus n minus 2 factors. So maybe this is telescoping. So we're going to start off with the test for divergence. So the limit as n approaches infinity, 1 over n squared minus n minus 2 gives me 1 over infinity. And this is important, guys, because most of you screwed this up on your quizzes that got this far. What is 1 over infinity going to? 1 over something really big. Is that really big or is it really small? You got it. It's really small. It's going to 0. So this is equal to 0, and the test for divergence fails. So we need to do something else. So we know there's something else. The only thing left to do is telescoping series. So is it telescoping? Okay, so yes, we think it's telescoping. So we are going to now factor this thing. So that means we do partial fractions. Okay, so for our partial fractions, first we're going to factor. N squared minus n minus 2. What does that equal? You got it. N minus 2 times n plus 1. So 1 over n minus 2 times n plus 1 is equal to, we're doing the same technique that we did in the integral we did earlier, a over n minus 2 plus b over n plus 1, and we multiply that denominator over to get a times n plus 1 plus b times n minus 2. What are my zeros that I'm going to plug in here? N equals 2 and negative 1. So let's start with 2. And I will get 1 is equal to a times 3. So a is equal to a third. And then n is equal to negative 1 will give me 1 is equal to 0 plus b times negative 3. B is equal to negative 1/3. So this series then is equal to the sum n equals 3 to infinity of 1/3 over n minus 2 minus 1/3 over n plus 1. And it's a subtraction, so probably telescoping. So then we look for the nth partial sum, the general term of the sequence of partial sums. That's my S sub n. We can use a capital N down there if we want to. I don't know why I have a tendency to not. Notice I'm leaving that 1 over third on top, same as I would have done for an integral. I'm not bringing the 3 down to the bottom. It's probably telescoping because we know that a telescoping series is of the form a sub n minus b sub n. It's really subtraction that leads me to think of telescoping. Okay, so now this is where it gets a little challenging. We start expanding until we can cancel something out. So notice I start at n equals 3 down here. So the first number I'm going to plug in is 3. And I'll have 1 over 3 over 3 minus 2, that's 1, minus 1 over 3 plus 1, that's 4. Plus the next number I'll plug in is 4. I still can't cancel anything out, so I'm going to plug in something else. And the next number I'll plug in is 5. And I still can't cancel anything out. So that means I'm going to have to plug in something else. Now can I cancel something out? Yes, now the negative 1/3 over 4, oops, that's not how I wanted to cancel that out. That negative 1/3 over 4 cancels out with the positive 1/3 over 4. And I found my pattern of cancellation. My pattern here, actually I'm going to write it a little lower. My pattern here is negative skip 4, cancel positive. How many things did I have to plug in to see the cancellation? How many numbers did I have to plug in to see the cancellation? 4, which means that I'm going to need 4 numbers at the end as well. So I'm going to do this a little differently. So if I have n, remember the number before n is n minus 1. So the number before that is n minus 2. What's the number before n minus 2? N minus 3, you got it. So that's going to be the first thing that I plug in here. So I'm replacing n with n minus 3. So I have 1/3 over n minus 5 minus 1/3 over n minus 2 plus. Then I'm going to plug in n minus 2. And I'll have 1/3 over n minus 4 minus 1/3 over n minus 1. Then I'm going to plug in n minus 1. What will I have here? What will be inside when I plug in n minus 1? You got it. So I'll have 1 over n minus 3, 1/3 over n minus 3, minus 1/3 over what? One-third over n. And then when I plug in my n, that last thing is going to give me just what I have in my original thing. So 1/3 over n minus 2 minus 1/3 over n plus 1. And now let's see if our pattern continues. Negative 1/3 over n minus 2, skip 4. Look, I do. I have the 1/3 over n minus 2 positive. So those things cancel out. Okay, any questions so far? Now we want to continue our pattern of cancellation. So I'm going to go to the next negative. Negative 1/3 over 5. Skip 4. 1, 2. I pretend, wait, no, 3, 4. I pretend the plus dot 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 is not there. And I'm going to cancel with the next positive I see. So that 1/3 over 5, negative 1/3 over 5, I'm going to cancel out with that. Then I'm going to move to my next negative. So my next negative is 1/3 over 6. And I'm going to skip 4. 1, 2, pretend the plus dot dot dot's not there. 3, 4, and I'm going to cancel with the 1/3 over n minus 4. Okay, then I go on to my next negative. My next negative here is this. What am I going to cancel that out with? You got it. So 1, 2, 3, 4, cancel out with the next value I have there. So we're going to cancel out like that. Then I'm going to move to my next negative. My next negative is this right here. 1, 2, 3, 4. Do I have anything to cancel with? No, so I keep it. So what that means is now my S sub n is equal to what's left over in the beginning, 1/3. I have that 1/3 left over. 1/3 over 2 plus 1/3 over 2. That's left over. Plus 1/3 over 3. That's left over. I got 3 things left over in the beginning. Do I have 3 things left over in the end as well? Yes, I do. I have minus 1/3 over n minus 1. Minus 1/3 over n. Then minus 1/3 over n plus 1. So far, so good? So then this, we're looking at the limit as n approaches infinity of s sub n, which is 1/3 plus 1/6 plus 1/9 minus 1/3 over n minus 1 minus 1/3 over n minus 1/3 over n plus 1. What are these things going to? I don't understand your question. So like, what do you mean we went forward to the right? Can you try to explain your question a little bit differently? I'm not sure I understand your confusion. Okay, well then maybe I'll just talk about it briefly and hopefully I'll get your question. So it doesn't, like, if I wanted to think about it going from right to left, then I would be like, positive, skip 4 to the left, cancel the negative. Okay, so let's look at the positive. Let's look at the positive that, let's look in terms of this. I'm going to highlight things. So positive, skip 4. 1, 2, 3, 4. Cancel the negative. So basically, we're just kind of figuring out what cancels out here. So our pattern said, look at the negative one, skip 4 things, and then cancel it with the positive after that. So if I'm at this right here, negative 1/3 over 5, then I'm skipping the 4 things, 1, 2, 3, 4, and I'm canceling the next positive I see. Well, the next positive I see is the 1/3 over n minus 5, so that gets canceled out. And when we look at what the pattern was, the first thing that we saw that canceled out was that 1/3 over 4. The negative 1/3 over 4 canceled out with the positive 1/3 over 4. So I started with the negative, and I skipped 4 to the right, and then I canceled out the positive. Did that help at all, Jonathan, / Jay, and Jay? So this one's actually a really big problem because the pattern's actually quite big. We'll finish it, and then maybe we'll go back and just briefly look at a simpler one where we can see how things cancel out more easily, maybe. Okay, and then maybe it'll help you to go back and understand what just happened here, because it's kind of became a mess at this point. So we could not do positive, skip 4, and cancel negative in this case. That doesn't mean that that wouldn't be a pattern in some other case. But the reason we can't do it here is because when we look at how things actually cancel, my negative is canceling out with my positive that comes later. I could say positive, skip 4 to the left, and then cancel the negative. Yes, you always end by replacing with n. Okay, so if we need to, we'll talk about this a little bit more, but let's finish the problem first. What are these 3 things going to? 1/3 over n minus 1, 1/3 over n, 1/3 over n plus 1. As n goes to infinity, what are they going to? Zero, you got it. They're all going, oops. They're all going to 0. Which means that this is equal to 1/3 plus 1/6 plus 1/9 plus 0 plus 0 plus 0. So that is 6 plus 3 plus 2 over 18, which is 11 over 18. Now this was one of the 2 times that we could figure out the sum. S sub n is going to 11 over 18, So my final answer is that this converges to 11/18, the end. That's it, that's the answer.
If you go up a bit,
Yes.
why is it n-3 and then n-2 and then n-1?
Because we're saying the very last thing that I'm plugging in here, when I'm looking at like what this thing is going to, the very last number I'm plugging, I'm in the wrong place. The very last number I'm plugging in is in. That was an eraser, give me a second. Is in. So I know that the very last thing needs to be in. But what's the number right before in? Well, that's n-1. What's the number right before n-1? Well, that's n-2. And the number before that, that's n-3. So like if my last thing were, for example, if I had the sum of n equals 1 to 8 of whatever, a sub n, then I would be like a sub 1. Actually, let's actually do a thing, 1 over n. Then I would have like 1 over 1 here, plus 1 over 2, plus, and if I ignore the middle terms, the last thing I'm plugging in is 8. So I would have 1 over 8. What's the thing I'm going to plug in before 8?
1 over 7?
7. So
But
then
like,
I would
would it have been like 1 over n-4, for example? Or like you have to start at like a certain point?
well, okay, so I know that I'm ending it in, right? I know that the very last thing I'm plugging in is in the same way that down here, I know that the very last thing I'm plugging in is 8. That's the first thing. The second thing is I also know that it took me 4 things in the beginning to figure out what my pattern was, to see something cancel. So like here, let's write that down because that's important.
Okay, yeah, so you have to have like the same numbers of like things on each side of the pluses.
Exactly. So it took
Okay.
4 things in the beginning to see something cancel. So that means I need 4 things at the end. Does that answer your question?
Yeah, thank you.
Okay, are there any other questions about this? And Jonathan, did we get the answer to your question well enough, or would you like to talk about it again with another problem that's maybe a little less messy? Okay. Are there any other questions? Okay, well then we're done. If you need me for anything, please don't hesitate to ask. Remember that you are still required to come to class tomorrow to sign your cover sheet with me, and I need to see you doing that and like see your face and stuff like that. So just remember that in class tomorrow, that's what's happening. Plus, if you have questions about the test, you can ask them then. Sound good?